How do you apply the Pythagorean theorem and its converse? This is one of my favorite topics to discuss and cover in mathematics. And we're going to go ahead and discuss how to apply the Pythagorean theorem and its converse throughout the video. This is for Chapter 8, Section 1. Make sure this title goes at the top of your notes, along with the title of the chapter and section that you can get from your textbook. Here is a reminder of what your notes should look like for taking notes for this video. Remember that there's no video title 2 or 3. There's only a video title 1. And Chapter 8, Section 1 goes up top. Write your notes, and once you have your notes, review the notes, and then answer the video question for your summary. I'm going to go quickly through this section because this is all review. You have practiced the Pythagorean theorem over the last couple of years of your school years, and so this should be nothing new for you. So here's Pythagorean theorem. It tells us that a squared plus b squared equals c squared. So they're saying that this leg squared plus this leg squared, so the sum of these two legs squared is equal to the hypotenuse squared. And C is always the hypotenuse. A and B could be changed. It doesn't matter since addition is commutative anyways. And that is an algebra property that helps us to know that no matter which side is A or B, it doesn't matter as long as C is always the hypotenuse. Just a reminder, Pythagorean theorem works for all right triangles. It's only used to apply to right triangles. So let's talk about what a Pythagorean triple is. I have some of them memorized, but not all. So a Pythagorean triple, sorry, I keep moving, I don't mean to do that. A Pythagorean triple means that once I figure out the side length for C right here, that I'm going to end up getting a whole number. And a Pythagorean triple just consists of 3 whole numbers. And remember, the 3 whole numbers represent the side lengths of the triangles. Of course, you can get side lengths to be decimals and fractions and irrationals, but a Pythagorean triple has all 3 sides equal to whole numbers, okay? So we're going to look for this side. To do that, we're going to use Pythagorean theorem. So 21 squared plus 20 squared will end up giving us what and remember, we'll label this as C, will end up giving us what C squared is. So let's go ahead. I'm going to use my calculator because these are going to be using large numbers. So 21 squared is 441 plus 20 squared, which is 400. Oops, 441. And this is equal to C squared. 441 plus 400 is 841, which is equal to C squared. And so because I know this is a Pythagorean triple, it should be a whole number. So 841. And now I must take the square root of this side. So you remember, we take square root of both. So C should equal 29. Okay, and notice it's a nice whole number. So this is a Pythagorean triple. I know there's one that's like 3, 5, 3, 4, 5. Yeah, 3, 4, 5 is a Pythagorean triple as well. Now, taking a look at this example, think about this. Could the side length of C be less than 20 or 21? Hopefully you answered no, because remember the hypotenuse is always along a side. So our answer should have definitely been larger than 20 or 21. And it is, and it checks out. So this is a Pythagorean triple. This is not a Pythagorean triple, but we can still apply the theorem to this right triangle. And we're going to be looking for the missing side length of x. So that could be A or B. Notice that it says leave your answer in simplest radical form. I want to remind you to pause the video, write down what's on the slide, and then resume when you're ready to follow along with me. So we're going to do x squared plus 8 squared is equal to 20 squared. And so I have x squared plus 64 equals 400. 400 minus 64 is equal to, so x squared is equal to 336. I'm going to square root both sides. So the square root of 336 is, oh, you remember we have to leave it in simplest radical form. And I just used my calculator and I got a decimal. But you cannot get a decimal. You have to simplify the radical, and this is what we practiced before Thanksgiving break. So let's go ahead, and I'm going to minimize the slide and do the simplifying the radical on the side. So I have the square root of 336. Remember, you can use this to break down and use the factor tree to help break down your radical. And 336 is even, so I'm just going to divide it by 2. So I get 2 and 168. Divide this by 2 again. and I get 2 and 84. 84, I can divide that by 2 again, and I can get 2 and 42, and now I'm ready to begin. I can do 7 and 6 on that one. That's easier, and then 2 and 3. Now I'll go and circle all my ends, and remember, I can only take out perfect pairs. So here's a perfect pair of 2's and another perfect pair of 2's, so I'll get 4, because 2 times 2 is 4. And then inside the radical, I'll get 7 and 3 that are left, because they have no pairs, and so that'll be 4 rad 21. And you should get the same decimal answer. So this is what our value for x is, and that is the simplest radical form. Now that we know what Pythagorean theorem is, we can use it to find the area of a triangle. So remember the formula to find the area of a triangle, it's one that you should have memorized by now, which is 1/2 base multiplied by height. My base is 20, but notice my height is missing. So that's what I need to find. And to find the height, I can use Pythagorean theorem. Now, because this is 12 and this side is 12, then this is going to bisect that angle and also bisect the sides. So this is going to be 10 and 10. And that's only because these two sides were 12 and 12. And now I can use Pythagorean theorem to help me find the missing side of h by just focusing on this side of the right triangle. And now I have h squared plus 10 squared equals 12 squared. H squared plus 10 squared is 100 equals 144, which is 12 squared. Subtract 100, so h squared equals 44. And so now I have h, take the square root of both sides. So h is equal to the square root of 44. And I should simplify it further to its simplest radical form. So I'm going to do 44 would be 4 and 11. And I could just square root the 4 right away and know that I get 2. So it should be 2 radical 11. And so now that I have what h is, I can plug that in here for this h and find the area of the triangle. So I'll do that in black now. So the area is going to be 1/2, the base is 20, and multiplied by the height, which is 2 radical 11. I could take half of 20, which would give me 10, and I'm multiplying this by 2 radical 11. I can multiply the outside numbers and get 10 times 2, which is 20, and multiply that by radical 11, and that is the area of the triangle. Notice that in order for me to find the area, I first needed the Pythagorean theorem, which is why we learned that first. Okay, here's an example to try on your own. So go ahead and try by yourself and bring your solution to class, and we'll discuss this example in class. Here is the converse of the Pythagorean theorem. So this is actually a way of looking at it backwards. Before we were told that in order to find that Pythagorean theorem would tell us that the sum of the two side lengths will equal the square of the hypotenuse. So that was, I'm sorry, that was a little bit funky. So the first part, the Pythagorean theorem first told us that if you have a triangle and you have a squared and b squared and you add those two sides, it will give you what c squared equals. Now we're going to go backwards. That if the square of the length of one side of the triangle is equal to the sum of the squares of the lengths of the other two sides, then a triangle is a right triangle. So what they're saying is that they're going to give you a triangle and some side lengths, like 3, 4, and 5. And if Pythagorean theorem works, that means that 3 squared added to 4 squared will equal to 5 squared, then it will be a right triangle. So this will go ahead and equate to a right triangle. But we have to check it with Pythagorean theorem, and that's what the converse is telling us to do. So to summarize what I just said, the Pythagorean theorem will give you a right triangle and tell you to find the missing sides. That's what I illustrated up here in black. But the converse, or the opposite of the Pythagorean theorem, is saying, well, here we're going to give you all the side lengths, but now tell us, is it a right triangle? Okay, is the triangle a right triangle? Here are two examples to apply the converse of the Pythagorean theorem. I want to know if I squared this side and added together, will it equal this side squared? And same thing for this triangle. Write yes or no, and then resume when you're ready to follow along to see if you were correct or not. Okay, let's see if we got it right or not. So does 169 plus 756 equal to 7225? So what I did was I squared 13 and got 169. I squared 84 and got 7,056. And then I squared 85 and got 7,225. And if I add 169 and 7,056, I will get 7,225. So the answer is yes, this is a right triangle. And I proved it by using the Pythagorean theorem. And now let's take a look at the second triangle. Does 16 squared, which is 256, added to 48 squared, which is 2,304, does that equal 2,500, which is 50 squared? The answer is no. So this is not a right triangle, but it could be an acute triangle or an obtuse triangle. So let's see how we can apply the converse of the Pythagorean theorem further. You can actually classify a triangle as being right, obtuse, which is greater than 180, or acute, which is less than 90 degrees. So if the square of the length of the longest side of a triangle is greater than the sum of the squared lengths of the other two sides, the triangle is obtuse. So here is an example. If c squared, which is the hypotenuse squared, is greater than the sum, then the triangle is obtuse. So now let's follow along in the same path. Remember, we just discussed that if c squared is greater than the sum of the two sides, then the triangle is obtuse. So this is when it's greater than the sum. When it's less than the sum of the two sides, it is acute, which is smaller than 90 degrees. Remember, this one is greater than 90 degrees. And this one is less than 90 degrees. And when it equals 90 degrees, that's when the triangle is a right triangle. And that's the actual Pythagorean theorem. So let's take a look at some triangles to see what type of triangles we can classify them as. So here are three examples. We are given the lengths of the sides of a triangle, and we want to know, are they acute, obtuse, or right? So we're going to have to look at Pythagorean theorem and see if the sum is greater than, if the sum is less than, or if the sum is equal to 90 degrees. What type of triangle will it be? Go ahead and practice the Pythagorean theorem and check to see what the classifications are for each triangle, and then resume when you're ready to follow along with my answer and check your solutions. Okay, let's go ahead and check our answers. So 36 plus 121 is actually 157. So the 196 is greater than the sum of the two sides, which means that the triangle must be obtuse, greater than 90 degrees. 144 plus 169 is equal to 313. And so the sum for this one is going to be greater than the actual hypotenuse length. Therefore, this is an acute triangle. And for the last one, 49 plus 64 is 113. And that is going to be greater than 81. So once again, we have another acute triangle. So no right triangles in this bunch. Okay, bring all your questions to class, rewatch the videos. Don't forget to do your summary, and I'll see you the following day.